this is like 1A. Notice, 1A and 1B go together. So I am giving you a log base 3, same base number. It's got an x plus 4 in it and a minus 2. So consequently, where did this baby just shift to?
Left 4 down 2.
Left 4 down 2. We all know why left 4 down 2?
Yeah, you change the 1 in the parentheses.
Yeah, you change the x when it's in a quantity, you change the sign. So we're left 4 down 2 for both of these. And then you have to create the t-table that goes with them. So your t-table is just, in this case our base is 3, you're just doing what's 3 to the x power. So how do you plot those points?
1, 2, 3.
Yeah. And then you're going to do
0 to the third power is
3 to the 0,
3 to the 0.
3 to the first, 3 to the second, 3 to the third. So you're going to get 1, 3, 9, 27, which we're not going to graph.
Left 4 down 2.
Is that not what I did? I went left 4 down 2. Okay. Okay, so when you do the exponential function, it's going to, which way does its asymptote go?
It goes up and down.
On the exponential? On the 3 to the x?
Oh, that one goes sideways.
That was the exponential has an x in it, so it goes on the x-axis. Goes horizontal. So this one goes, yeah, okay, this one goes horizontal, and we plot those points. 0 over 1 up, 1 over 3 up, 2 over 9 up, and I'm not doing 27. And so, from that new origin, that's the kicker. I wish I could get it brighter. Give me red.
Whoa, Betsy.
There was the new origin. Okay, so then logs are easy. Once you've got that done, how do you do the log? Yeah, you just switch it. To do the log, you simply change the coordinates. The 0, 1, 2 go on the right side, and the 1, 3, 9 come over here on the left side. Exact same coordinates, exact same start point. Where's your asymptote?
Goes vertical.
Yeah, logs are vertical.
A and B are graphing the same way.
Yeah. So 1 over 0 up this time. Not 0, 1, but 1, 0. So you're going over 1 up 0. Then over 3 up 1. 1, 2, 3, 1. And then over 9 up 2. So logs grow really, really slow. So this will not rise fast.
So when we draw it, you don't want us to put a big old slope up?
Yeah, it's not going to go shooting up. It's going to rise very, very, very slowly, and it's going to go zooming down the asymptote. And you can see they're inverses of each other. They're a perfect reflection of each other.
Wait, they reflect over y equals x?
Yes, they reflect over y equals x. Yep. If y equals x goes through your new shifted origin.
When the next one is 2 and it's negative x, and now everything equals negative.
Okay, think of that, since that one's got a negative x on it, you've got that next one has 2 to the negative x plus 3. You can't tell where to shift if there's a negative on your x, so you have to factor the negative out, which will make you have x minus 3. So you're going to go right 3, but the negative's going to make you flip. Now, which way does that negative make you flip? Does it flip over the x or over the y? Are you sideways flipping or up and down? This is y-axis flipping. So normal exponential functions rise to the right. If there's a negative on it, yeah, this will actually be exponential decay.
Ew.
And the same way, a normal log curves off to the right.
It's going to curve off.
So this one's going to curve off to the left.
So would it just be over right 3?
Yes, it'll just be right 3, and there's no up or down because they didn't add any number on the end. Yeah.
Whoa.
Whoa. So, you mean when you plot your t-table? When you t-table it, you just do 2 to the x. Just always, you'll never do anything else on the t-table but that base number to a power. Always. I don't know what you mean by the first one.
On the
Oh,
bottom,
normal exponential functions rise to the right, they grow fast.
but his negative is
The decays, yes, yeah. Negative
So
decay.
this one, 0, 1 is gonna go this way?
Yeah, 0, 1's gonna come left. Alright, oh sorry, okay. Are you on the exponent? 0, 1 is still up, it's just that you're gonna rise going on the left side instead of rise on the right side.
So it'd be 0, 1, 1, 2, 2, 4, 3, 8.
Yep. No, don't switch your coordinates to negative. You just have to know that that flip makes you rise on the other side. So I'm out of space here. Can I? Not that. So I'm gonna go. You're gonna go 0, 1, 2, 3. You're doing 2 to the x. So 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. But you're just going to rise. When you do 1, 2, you're going to go left 1 up 2, left 2 up 4, because you know it's got to be exponential. Your origin in this case shifted right 3. That's it. You don't have any up or down. So on this one, yeah, everything's going to the left on this one. Instead of going, normally 0, 1 is still straight up. But when you go 1 over 2 up, you're just going on the left. 2 over 4 up, you're just going left. So it's just going to come, and so it's going to come down into that asymptote. You're just going to decay. If you flip it. Normally, everything's going to the right. Normal exponential functions rise to the right, logs go off to the right. If you got this negative on it, everything's going left. But guys, I need to move on to nothing more than if we're going to review, I need to get past that. Okay. On number 2, write, make common bases.
Wait, on what number?
Number 2, write, make common bases.
Hey, I'm not.
So I'm going to get you started. I'll let you all finish. What's the common base number that you could write both 49, 7? They're both 7 to a power, aren't they? Okay, Keegan says that's 7 to the negative 2. Do y'all follow why?
Yeah, because you have to flip it over to the inverse.
That's 7 squared. When you bring it up, becomes negative. And this is 7 to the 4y minus 9.
Wait, why did you put negative 2? Oh, never mind.
Because I brought it up.
Because you lost a lot.
Yeah. And so therefore, that's really 7 to the what then, when I have those two together? Do I add those or multiply? Yeah, it's just negative 2y. And so then you can, once you have the bases equal, you can
Drop the base.
drop the bases, that's powers equal, and solve it. So, I'll let you all finish it. Okay, those kind of problems, I have to give you numbers that will easily change into common bases. I can't give you something bizarre and weird. Okay, 3 is actually really easy, but it was way back at the beginning, so I want to make sure you remember how to do ones like 3. I'm not going to do the ones on 3. So if I said to you, what's the log base 8 of 64? We'll do a nice easy one. How do you quickly do a log? What?
Because, 8 squared.
Remember, you need to rewrite the 64 as 8 to a power. So that would be 8 squared. If the log has a base 8 and the exponent has a base 8, they cancel out. They're inverses. The answer's 2. So you just got to make them have the same base.
Wait, what number is this?
Like number 3. Let me ask you this. What if I gave you log base 17 of the cube root of 17? Why?
Because, the cube root of 17 is
Yeah, you have to rewrite that as 17 to the 1/3. Because, so then it cancels out, and the answer is 1/3. So that's all I'm looking for on those kind of problems.
So then log 3 of 81, how did they get?
81 is three-wheel power. If you don't know, get out your pink sheet. Yeah, pink sheet might still be handy. And then, of course, what do you know happens with any natural log problem? If I do a natural log of an E, it cancels, and your answer is 1021. Those automatically take each other out. You love those signs. That's the easy stuff. Okay. 4 and 5 are usually the sticking points of this test. The end part of this is all the logging and clogging you just did today on your on those word problems, which doesn't tend to be a problem. It's usually 4 and 5 that if we're going to get stuck as far as big point items, these right here aren't going to be worth tens of points.
Oh, no, turn back that corner.
What? Are you talking to me or to some? Are you talking to me or somebody else? Okay, because I'm not sure what you're talking about. Turn back the exponential. Okay, on 4. Notice, on 4, every single problem, how many logs are there? If there's a log on only one side, what do?
Add another log.
Change the exponential form. Write that on number 4. Now, the next question is, do you remember how to change the exponential form?
I'll take that as a no.
So 3 equals x to the 1/3.
So, you got a choice between 4, A, B, C, or D. Which one do you want?
Yeah.
A? Well, okay, so, you look at it, you got log on one side. When I change the exponential form, ask yourself which number is always the base.
1/3.
That's log base. The little number is base. That's always x, and it's always x. The power is 1/3. Logarithms equal their exponents. Logarithms represent exponents, so that's the exponent. So it's got to equal 3. Now, how do we get rid of a 1/3 power?
You ought to.
Don't forget, like inverse, like something like that.
The easy way, if you got a 1/3, what would make a 1/3 cancel? But that's, so I would have to do the same thing to the other side, take it to the third power. Those cancel, and x equals 27.
If you do this in your sleep, you need to become a math teacher. I bet you that's what it's like.
Actually, I don't know, because when I sleep really heavy, and I hardly ever remember any dreams, so if I do math in my sleep, I don't know it. All right, as opposed to, on number 5, how many logs do you see in the problem?
2.
Multiples, 2 or 3 or more. Okay, so that's when those properties come up.
Those are the easy ones.
What do you do when you see a log plus a log?
Times
You multiply those two together.
Log 'em.
When you see a log minus a log,
Divide.
you divide.
Log.
And then the third rule, the plug rule, you can move a number in front or you can move it back to the power wherever you want it.
Hey, I think
So-
we do 1 on 5.
Let's do
So
5.
they normally solve for x like you would any other. So somebody got a preference on 5?
5C.
5C?
Yeah.
Okay. 5C. This is a good one. It's got numbers in front. That'll help.
Yeah. I know. So you take them to the power.
Okay, and one more time, I will never give you a problem where the logs have different bases. You'll always have a base 5 log all the way across.
No,
That's what these
okay,
those
yeah,
things
I'm sure they were.
posit.
No, you can't.
Can I immediately combine this left side here?
No, because there's a half.
You got the yellow.
Yeah, you can't have the half. You can't have any numbers in front. So where do you take it?
Exponential form.
Yeah, we are bringing it. We're using the plug rule, and we're taking the 1/2 back up here so it's out of our way. But the big question is, what's 4 to the 1/2 power?
What's the 1/2 power?
2.
Okay, why is it 2? Because that is the square root of 4. That's 4 to the 1/2 power. That's a root. That's not 4. It's not a half because you took 4 times a half. It's because it's the square root of 42. Now, what do you do when you have a log plus a log?
Hey, you lost your 5 on that second log.
Oh, thank you. I did. I lost my base. So now, if I multiply them, what will I get?
Wait, I got this. 14.
7 times 2 is 14. And so therefore, now you're down to 1 log on each side. They have the same base. So if the logs are equal, then
They cancel.
they cancel, and you can say the quantities inside are equal. Oh, you have to check your answer for what?
Plus or minus?
Nope. I mean, this one didn't have a square root, so it wouldn't be a plus or minus. But when you get done, what do you have to go back and look at in the original problem? If you stuck 4, you have to make sure it would be a positive number in your log. So you got to go back and check for positives. That's
Okay, so
important.
are you serious? Did the bell just ring?
The bell just rang.
Awesome. Awesome.